Welcome to our deep dive into amines, a fascinating and vital class of compounds in organic chemistry. Amines are organic derivatives of ammonia, where one or more hydrogen atoms are replaced by alkyl or aryl groups. Their unique structure and reactivity make them crucial in both biological systems and industrial applications. In this video, we'll explore the classification, properties, synthesis, and uses of amines, ensuring you gain a comprehensive understanding. Let's begin by laying the foundation and seeing why amines are so important in the world of chemistry. Amines are characterized by the presence of a nitrogen atom bonded to hydrogen and carbon atoms. They can be thought of as derivatives of ammonia, NH3, where one or more hydrogens are replaced by organic groups. This simple change leads to a wide variety of compounds with diverse properties and functions. Understanding this basic structure is key to grasping how amines behave and why they are so versatile in organic chemistry. Amines are classified based on the number of organic groups attached to the nitrogen atom. If only one group is attached, it's a primary amine. Two groups make it a secondary amine, and three groups result in a tertiary amine. This classification affects their chemical behavior and reactivity. Recognizing these categories helps in predicting how different amines will interact in chemical reactions. Primary amines have one alkyl or aryl group attached to the nitrogen atom, along with two hydrogens. They are often represented as RNH2, where R stands for the organic group. These amines are typically more reactive than their secondary and tertiary counterparts, especially in forming hydrogen bonds, which influences their boiling points and solubility. Secondary amines have two organic groups attached to the nitrogen atom with one hydrogen remaining. Their general formula is R2H. These compounds show different physical and chemical properties compared to primary amines, such as slightly lower boiling points and different reactivity patterns, especially in substitution reactions. Tertiary amines feature three organic groups attached to the nitrogen atom with no hydrogens left. Their general formula is R3, and these amines cannot form hydrogen bonds with themselves, which leads to lower boiling points compared to primary and secondary amines. Their chemical behavior is also distinct, making them useful in various synthesis processes. When all four positions around the nitrogen are occupied by organic groups, we get quaternary ammonium compounds. These are not technically amines, but they are closely related. They carry a positive charge and are important in many biological and industrial contexts, such as disinfectants and phase transfer catalysts. Amines can also be classified as aliphatic or aromatic, depending on the nature of the organic group attached. Aliphatic amines have straight or branched carbon chains, while aromatic amines have the nitrogen attached to an aromatic ring like aniline. This distinction impacts their reactivity and applications. Amines display a range of physical properties such as distinctive odors, varying boiling points, and solubility in water. Primary and secondary amines can form hydrogen bonds, leading to higher boiling points, while tertiary amines cannot. Their solubility decreases as the size of the organic group increases. Amines are basic in nature due to the lone pair of electrons on the nitrogen atom, which can accept protons. The basicity of amines depends on the type of amine and the groups attached. Aliphatic amines are generally more basic than aromatic amines, as the lone pair is more available for bonding. Hydrogen bonding plays a significant role in the properties of amines. Primary and secondary amines can form hydrogen bonds with water and with each other, which affects their boiling points and solubility. Tertiary amines, lacking NH bonds, cannot form such bonds, resulting in lower boiling points. The solubility of amines in water decreases as the size of the alkyl group increases. Smaller amines are quite soluble due to hydrogen bonding with water, but as the organic portion grows, the molecule becomes more hydrophobic, reducing solubility. Amines are notorious for their strong, often unpleasant odors. Many low molecular weight amines smell like ammonia or rotting fish. This characteristic is due to their volatility and the presence of nitrogen, which is easily detected by our sense of smell. One common method to prepare amines is the alkylation of ammonia. In this process, ammonia reacts with an alkyl halide, replacing a hydrogen with an alkyl group. This reaction can produce primary, secondary, or tertiary amines depending on the amount of alkyl halide used. The Gabriel synthesis is a specialized method for preparing primary amines. It uses phthalimide as a starting material, which reacts with an alkyl halide and is then hydrolyzed to yield the primary amine. This method avoids the formation of secondary and tertiary amines, making it highly selective. Aromatic amines, such as aniline, are often prepared by reducing nitro compounds. This process typically involves using reducing agents like iron and hydrochloric acid or catalytic hydrogenation. The nitro group is converted to an amine group, providing a straightforward route to aromatic amines. Reductive amination is a versatile method for synthesizing amines. It involves reacting an aldehyde or ketone with ammonia or an amine, followed by reduction. This method allows for the creation of primary, secondary, or tertiary amines depending on the starting materials. The Hofmann rearrangement is a reaction that converts amides into primary amines with one fewer carbon atom. This reaction uses bromine and a strong base and is particularly useful for preparing amines from carboxylic acid derivatives. Amines can be gases, liquids, or solids at room temperature depending on their molecular weight and structure. Lower amines are usually gases or liquids, while higher amines tend to be waxy solids. This variety in physical state is linked to their ability to form hydrogen bonds and their molecular size. The boiling points of amines are influenced by their ability to form hydrogen bonds. Primary and secondary amines have higher boiling points than tertiary amines but generally lower than alcohols of similar size. This is due to the difference in hydrogen bonding strength. Amines are generally basic, but their acidity and basicity can be influenced by the groups attached to the nitrogen. Electron-donating groups increase basicity while electron-withdrawing groups decrease it. Aromatic amines are less basic due to resonance effects. Amines react readily with acids to form ammonium salts. This reaction is important in both laboratory and industrial settings as it allows for the purification and isolation of amines. The resulting salts are usually more water-soluble than the parent amine. Amines can react with alkyl halides to form higher amines or quaternary ammonium salts. This reaction is the basis for many synthetic pathways and is widely used in organic synthesis to build complex molecules. Amines react with acyl chlorides or anhydrides to form amides in a process called alkylation. This reaction is important in the synthesis of peptides and other biologically active molecules as it links amino acids together. Primary amines react with nitrous acid to form diazonium salts, which are important intermediates in dye and pharmaceutical synthesis. Secondary amines form nitroso compounds, while tertiary amines do not react under these conditions. The carbylamine reaction is a test for primary amines. When heated with chloroform and alcoholic potassium hydroxide, primary amines produce isocyanides which have a very unpleasant odor. This reaction is used as a qualitative test in the lab. The Hinsberg test is a classic method for distinguishing between primary, secondary, and tertiary amines. It involves reacting the amine with benzonesylphenyl chloride under basic conditions. The resulting products differ in solubility, allowing for easy identification. Amines play crucial roles in biology. Many neurotransmitters such as dopamine and serotonin are amines. They are also found in amino acids, the building blocks of proteins, and in vitamins and hormones. Their presence is essential for life processes. Many drugs and pharmaceuticals contain amine groups. These functional groups are key to the biological activity of medicines, including antihistamines, antidepressants, and local anesthetics. The versatility of amines makes them invaluable in drug design. Amines are widely used in industry. They serve as corrosion inhibitors, surfactants, and in the production of dyes, rubber, and plastics. Their chemical reactivity and ability to form stable compounds make them essential in manufacturing processes. In agriculture, amines are used in the synthesis of herbicides, pesticides, and fertilizers. Their ability to interact with biological molecules makes them effective in protecting crops and enhancing growth, contributing to food security worldwide. Amines are present in many everyday products, from cleaning agents to cosmetics and dyes. Their chemical properties allow them to act as surfactants, emulsifiers, and colorants, making them a part of our daily routines, often without us realizing it. While many amines are useful, some can be toxic or irritating. Proper handling and safety precautions are necessary, especially in industrial and laboratory settings. Understanding their toxicity is important for safe use and environmental protection. Amines released into the environment can have significant effects, including water pollution and harm to aquatic life. Proper disposal and treatment are essential to minimize their environmental footprint and ensure sustainability. Detecting and analyzing amines is important in both research and industry. Techniques such as chromatography, spectroscopy, and chemical tests are used to identify and quantify amines in mixtures, ensuring quality control and safety. Amines are key components in the production of polymers such as nylon and polyurethane. Their reactivity allows them to form strong bonds, resulting in materials with diverse applications from textiles to automotive parts. Aromatic amines are essential in the synthesis of azo dyes, which are widely used in textiles and inks. Their ability to form stable, colorful compounds makes them invaluable in the dye industry. In the rubber industry, amines are used as accelerators and antioxidants. They help control the vulcanization process and improve the durability of rubber products, making them essential for manufacturing tires and other goods. Amines are used in water treatment to control corrosion and remove impurities. Their ability to react with acids and metals makes them effective in maintaining clean and safe water supplies. In gas treatment, amines are used to remove acidic gases like carbon dioxide and hydrogen sulfide from natural gas and industrial emissions. This process is vital for producing clean fuel and reducing environmental pollution. Some amines occur naturally in foods such as histamine and tyramine and can affect flavor and health. Others are added as preservatives or flavor enhancers. Understanding their roles helps ensure food safety and quality. Amines are used in cosmetics as emulsifiers, pH adjusters, and preservatives. Their chemical properties help stabilize products and improve their texture and shelf life, making them common in lotions and creams. Many cleaning products contain amines as surfactants and disinfectants. Their ability to interact with both water and oils makes them effective at removing dirt and killing germs, contributing to hygiene and cleanliness. Research into amines continues to expand, with new applications in green chemistry, medicine, and materials science. Innovations in synthesis and sustainable use promise to make amines even more important in the future. Wrap up: amines are a diverse and essential group of organic compounds with wide-ranging roles in chemistry, biology, and industry. From their classification and properties to their synthesis and uses, understanding amines opens the door to countless scientific and practical applications. Keep exploring the world of organic chemistry, and you'll find amines at the heart of many discoveries.